Welcome back, everybody. Today we will build and find the volume of composite figures. So for those of you who are wondering, a composite figure is a figure made up of two or more three-dimensional figures. So here we see a figure made up of right rectangular prisms. Here we see a cylinder and a semi-sphere. Here we have a cylinder and a rectangular prism. Here's a triangular prism and a right rectangular prism. So all of these are three-dimensional, and we're combining them to make one shape. Okay, so let's go ahead and fill in our first piece made up of two or more, just like this one looks like it could be a three, two or more three-dimensional figures. Two or more three-dimensional figures. Okay, so let's say that you were working with a partner and you were asked to make a 3 by 2 by 2 unit figure, and your partner was asked to make a 2 by 2 by 2 unit figure, and you were asked to find the volume of each one separately. So let's review a little bit. Volume is the number of cubes that make up a three-dimensional shape. So here for a rectangular prism, or right rectangular prism, we use the volume formula length times width times height. Well, that would be 3 times 2. 3 times 2 is 6. 6 times 2, which is 12. So this prism here has a volume of 12. Okay? This prism here, length times width times height, we would do 2 times 2, which is 4, and then that 4 times 2, which is 8. So now we have one that has a volume of 12 units cubed, and one that has a volume of 8 units cubed. And we found their volume separately. Now, what if I told you I want us to combine these shapes, whether it's this way, or this way, or something funky like this, and I want to know the volume of this new figure? Well, my question to you is, how many cubes make up this figure? Well, I have 12 cubes here, I have 8 cubes here, so I have a total volume of 20 cubes, 20 units cubed, because I did my 12 plus 8 to get my 20 units. So I'm going to say first figure, second figure, and together then I would just add their volumes to find out how many total cubes make up this new composite shape. The volume of this figure is 20 cubic units. The volume of this figure is 20 cubic units because I have 12 from this shape and 8 from this shape. Okay? So, if I were to build another set of prisms, how could I find the volume of a composite shape? If I were to build anything else, how would I find the volume? Would my volume of each individual piece change? No. I would just be adding it to the volume of another shape. I would just be adding it to the volume of another shape. Let's look at an example problem here. What is the volume of this prism? Well, let's use our volume formula. I always like to write it down if I can. Length times width times height. And let's plug it in. 3 length times width, 2, times height, which is 7. 3 times 2 is 6. 6 times 7 gives us 42 meters cubed. Well, that's the volume of this shape. So imagine if I took that volume of 42 meters cubed, and now I have an identical prism right on top of it. If I glued them together to make a bigger prism, how could I find the volume? Well, the volume here is 42 meters cubed. What's the volume of this one if they are identical? Well, the volume of this one up here is 42 meters cubed. So to find the volume of the entire figure, I like labeling total volume. My volume would be 42 plus 42, which gives me 84 meters cubed. That's the total volume of this shape. That's the total volume of this shape. Moving on. Here I have a new composite figure. Okay, I color-coded it so it would be easy for us to see the different shapes that make up this figure. How many cubes make up this base layer here? Well, I'm not going to take it apart and have us count, so let's use the cubes that we see and use that to help us. Here I see that I have a length of 4 and a width of 2. So 4 times 2 gives me 8. 4, I'm going to label it here. 4 times 2. 4 times 2 gives me 8. And I'm going to continue with my height. My height, I have a height of 1. And 8 times 1 gives me a volume of 8 units cubed. That's just for the bottom base layer. Now we're looking at the top layer. The top layer has a 2 by 2, so 2 units by 2 units. Length times width. And I'm going to multiply that. That was 4. I'm going to multiply that 4 by my height of 1. And 4 times 1 is 4. So I have 4 units cubed for the volume of my top layer. What's the volume of the composite figure, and how do we know? Well, if my bottom layer had a volume of 8 units cubed, and my top layer had a volume of 4 units cubed, I know that I can take each volume and add them together. So over here, let's write total volume. I'm going to combine them, the volume from the top layer with the volume from the bottom layer, and get my total volume of 12 units cubed. 12 units cubed makes up this new figure. 12 units cubed makes up this new figure. Continuing on. What do you notice about this figure here, this image, compared to the others? Well, here I see a length times width times height. Here I see a length times, I don't see a width, and a height. Anything that you notice that would help us figure out the width of that top piece? Hopefully you see it. This line right here shows that that figure's side lines up with this figure's side, same thing over here. So that means that length, this length, this length, this length, this length, and this length are all the same. All of those widths are the same. So that means that I have a width here of 2 units. I have a width there of 2 units. So in this, we also have a difference because we don't see the cubes. We don't see these cubes that we've been counting like crazy. So if we don't have cubes, how can we figure out the volume? Same way as we've been doing it before. Let's do the top layer. The volume would be length, which is 2, times width, which is 2, times the height, which is 1. 2 times 2 is 4. 4 times 1 is 4. The bottom layer has a length of 4, a width of 2, and a height of 1. 4 times 2 is 8. 8 times 1 is 8. So this is what our last figure would look like if you couldn't see the cubes. We could find the total volume by simply adding the separate volumes together and getting our total. We could simply find the separate volumes, add them together, and get our total. But pay attention when it's not shown with cubes to the labeling and what has to be the same length. We don't want to guess. We see that this lines up here. We see that this lines up. So I know that those are the same lengths. I'm not guessing for that problem. Let's continue on. Find the volume of the composite figure. Find the volume of the composite figure. Here there's quite a lot of markings, so we'll need to be careful and make sure we use the right ones when we find the volume. First, let's go ahead and find the volume of this bottom right rectangular prism. And I see I have a length, a width, and a height. So I'm going to go ahead and write bottom volume, length of 6, a width of 5, and a height of 4. So I'm going to do my math. 6 times 5 is 30. 30 times 4, I don't know that off the top of my head. 4 times 0 is 0. 4 times 3 is 12. So this volume is 120 inches cubed. That's just for the bottom piece. Now let's go ahead and find the volume of the top. What am I missing? Here, they're showing me with these arrows that the length here is 3. They're showing me here that the height is 2, but again, I'm missing this width, the width there of that right rectangular prism. Well, if you notice, again, it's lined up, so here we have the same dimensions. Everything I've highlighted has the same width. So for my top volume, I'm going to use length, which is 3, times my width, which is the same as down here, which is 5, times my height, which is 2. 3 times 5 is 15, and 15 times 2 is 30 inches cubed. So again, we're going to find that total volume. This one has a volume of 30. This one has a volume of 120. So I'm going to add these together to get my composite or combined volume of 150 inches cubed. 150 inches cubed. Last part of our lesson. So we've been putting together these composite figures and finding their volume by adding the different pieces that we can figure out. I can figure out the volume of this right rectangular prism. Same for this one. I can figure that one out. I can figure that one out. So I take what I know, what I can already figure out, and I just put them together. So explain how you use addition to find the volume of composite figures. I use addition to find the volume of composite figures by adding the separate volumes I can already figure out. I know how to find the volume of rectangular prisms I simply add those volumes together. Alright, that's it for our notes lesson. If you'd like, click on another video link for the problem set help.